Hello again, Bob Hughes here with JD2. Thanks for tuning in. Anyway, in this RC6 project video, we're going to be building this truss right here. This is project number 2. This particular truss is actually going to support the floor in a house, so we only built one of them. We used the RC6 to cut all of the diagonals. We could have used it to mark the top and bottom beams. We didn't do that. Anyway, the thing is very large. It's 22.5 feet long by about 17 5/8 of an inch tall. And in this video, I'm going to break it up into 2 sections. The first section, we are just going to show the machine making the parts because that's what a lot of people are interested in. I think that's going to take about 12 minutes. After that, I'm going to show you how we created this part in our Camelot software, and then that way too, if you get one of our machines, you'll be able to do it. All right, without further ado, let's get after this sucker. I went ahead and zoomed in so that you could see we have installed the square tube stabilizer. As shown in prior videos on the stabilizer, we used our gauges to set our rollers. Very easy to do. We've also utilizing the universal jig plate for this particular application. These are very simple. They're essentially a plate with a grid, a 1x1 grid, 6 by 6 inches total, that has been drawn on it or engraved in it. And then we have different blocks that we could position in different locations in order to handle weird shapes, for instance, angle iron channel. In this particular case, we're only handling rectangular, so it was pretty easy to do. All right, let me go ahead and I am going to reposition and show you the machine in entirety so I can show you the next thing that we did to set up for this job. I'm at the far end of the RC6 rotary cutter to show you a couple things. In this particular job, we're going to be utilizing 2 lifters in the RC6. You can mount up to 4 lifters, but this job we're going to use 2. And what we've got is, this is the lifter right here. Now, we made the lifter so that we could alter the plates that we bolt onto it depending on what kind of profile we may want. So it turns out that for this 1.5 by 3 inch rectangular tubing, it's just about 3 1/4 inches from corner to corner, like this right here. So what I did, I went ahead and I made a plate that was 3.3 inches in diameter, or at least the arc is, and then we brought the sides up 1.5 inches. Now that will help support the rectangular tubing as we rotate, but keep in mind that it isn't going to do what the rings would do. And this, for instance, is a ring assembly on some square tube right here. This we would be able to roll in our bearing blocks and basically have perfectly smooth motion. We're not going to get that with the lifters and these plates. What we're trying to do is hold the tubing up, kind of hold it in the middle, so it's a little bit clunky. Now if you notice right here, I have a piece that is supplied with the machine. It holds up flat, and the reason I have it down here is whenever I home this machine, I place a piece down here that I can roll up like that right there, so that when the lifters fall, because whenever we home this machine, all the lifters have to get out of the way so that the head could go by. I'll use this to support the end of the tubing, so that's just a quick little tip for you right there. Anyway, I'm going to go ahead and place in the stainless steel guards so that our water is routed into the tray, and we'll start cutting on this thing. One of the first things we need to do after we load our tubing up is for the machine to know where the center of rotation is. So we're going to go ahead, we're going to go to the right top screen, and I am going to pick a wizard. And then here in the wizard, we have currently 3 choices. We have structural, round, or rectangular, square. Let's go ahead and pick rectangular. And all I have to do is fill out the boxes. One of them is asking for the tube width. We're going to put it 3 inches because when we created this program in Camelot, we started off with the large side is flat. So we're going to say 3 inches. Then we're going to go over here to tube height. We're going to say 1.5. And then the corner radius, we need to know a corner radius right here is 1/4 of an inch. So let's put that in. And then I can hit the generate button. And what it did, when I returned back to the plasma cut screen, it has generated a small program that the RC6 is going to run to find the center of this. So let me zoom in on that so you can see it a little better, and then I'll hit the go button. All we need to do is position the torch somewhere in the middle of the tubing, just above it, and we roughly have it leveled. It doesn't need to be precise. Let's hit the run button. So what it's looking for now is how far out of a line is the chuck. Do we have to rotate a little bit to get the top surface flat? All right. Now it's going to check both ends of the tubing to locate the middle of the tubing. Okay, we're done with that. The RC6 now knows where the tubing is at. Keep in mind that you only need to do that when you first load a piece of tubing. If we were doing 100 of these, we would not have to keep repeating this, only for the first job. All right, now we need to go ahead and load up our program. So I will go to File, Import NGC, and looking at the USB drive, I'm going to go ahead and pick floor truss number 1. This was the code that we generated earlier in Camelot. Now if we roll this over here, you can kind of see what's going on in the view, what we're going to be doing. All right, so the next thing we need to do is tell the RC6 where on the tubing do we want to start cutting. Let me reposition the camera and show you that. All right, I'm back on this end of the machine right here. Let's go ahead and run the carriage to the end of the tubing. Now, when we generally run a program, we're going to move the torch to where we want the RC6 to start executing that program. Notice the lifter is automatically lifting and getting out of the way. Now, what we're going to do, going to get a little bit of help here, we want to come as far as we can down this frame rail without actually going to the end. If we do go to the end, the carriage will not fall off the machine, but it will, however, hit the bump stops, which will reset the machine, making us having to rehome it. So we don't want to get that far down. We want to get to about an inch or so. The bottom line is this tubing that we put in the machine is a little big for the job we're doing. We could have cut it shorter, but you know, we just threw a piece of tube in. So, all right, Ryan, if you could do me a favor, just give me a heads up when I'm about 2 inches from that right there. We got different speeds that we could run the machine at. We're going to go medium speed. Now we're going to go slow. How far? Good right there? All righty. So what I'm going to do now is I am going to select Y0 under Quick Work Offset. And what the Y0 setting is going to do is the RC6 now figures that this, as far as that program is concerned, is the 0 point. We're going to start cutting at this particular location right here. So let's go ahead to back to the other end, and we're going to run the program. However, if we turn on the coolant, we're going to run off we're going to flow out over here. So give me a second to figure out what I want to do there to prevent that from happening, then we'll run the program. Devin came up with a pretty good idea on how to seal the end of the tubing. Just simply use packing tape. As soon as we cut through the tube here, the coolant will start running out that side and we won't have an issue anymore. So the only thing we're going to need to do now is go down, tell the RC6 what is the material we loaded, mild steel 125 wall. That's the subject of another video. You can check that out. But let me walk down to the other end. In the meantime, Ryan, if you could do me a favor and zoom in a little bit so that they could see the stuff being cut and marked. All righty. All right, way down here, I am going to go to select my settings. I'm going to pick mild steel. We're going to pick 10 gauge, and we're pretty much good to go. All right, let's hit the run button. All righty. First thing it's going to do is use the marker to mark. Looks like it's going to be number 24. It is. I'm going to come over here to this side so that when it cuts, I'll just remove this piece out of the machine. A lot of coolant. Now, I can catch every single piece, or I could just let them fall. Let's watch it fall. No big deal. Once again, it has grabbed the marking tool. This is probably going to be number 23. Yep. All righty. You can see the automatic lifters retracting. Yeah, you know, a little bit. All right. So if we look at one of our pieces right here, you can see very little slag. Well, I think you can see it. But this is what we're going to be putting together to create that truss. No marks. We've completed the first program. We've cut out basically 10 of these parts here. You could see that, I think you could see that we have marked them. So this is part number 21. I am now going to go ahead and load up the second piece of tubing and we'll process that one. Go ahead and turn the marker on, push the button. That looks nice. I had to put a new marker in it. The other one kind of ran out of ink. Oh yeah, it looks really good. Nice 13. Okay, I'm going to go ahead and pull the camera off the tripod so that we can get a little closer view here what's going on. Alrighty. It has dropped the marker. Now it's going to mark this part number. Part number 11. Okay, we'll let this continue cutting. I think it's only got 2 more parts. So I'll go ahead and kill it right here and then I'll show you the finished product. Well, we did it. This is our truss. Takes about 4 people to move this thing. It's heavy as all heck, 22.5 feet long. And you saw us make all the diagonals in the RC6. We could have done the verticals too, but sometimes a saw is the way to go, and this was one of those cases. Well, I hope this video was educational, both parts of seeing how the machine cuts and also Camelot. I am doing a lot more projects right now. I'm going to be trying to do about 3 a week here for the next few months. So if you get bored, go ahead and subscribe to our channel and then take a look at some of them. Some of them are pretty darn cool, like the wedge cuts in the square should blow your mind. Anyway, for JD2, I really want to thank you for watching. Hope you have a great day. Goodbye. Hello again, Bob here. In this video segment, I'm going to show you how we created that floor truss. I created a drawing earlier in Inventor. I did not apply weights, so we could disregard this 35 pounds. I was pretty much more interested in dimensions. Anyway, this is the truss that we're going to build. Now, the way it worked out, that all of these parts here, or a lot of them, are actually different from each other, even though they look exactly the same. And the reason for that is in this particular truss, when they were measuring everything, they had to clear certain pipes, wires, ducting. So that's how it became where these are non-standard diagonals. Now, what we're going to do in Camelot to make this job easier to process for the welders, we're actually going to place part numbers on those individual diagonals in order to allow the welder to identify what location they go in. All right, anyway, you can clearly see that the structure is made out of 1.5 by 3 inch by 125 wall rectangular tubing. The first thing we're going to need to do is import the step file that was exported by SolidWorks. Now, Camelot has the ability to import step files, which are essentially 3D representations that most major programs in the world, CAD programs such as Inventor, Fusion 360, SolidWorks, CATIA, on and on and on, can output their 3D structures as a step file, and we can bring that into Camelot. So since we did export from SolidWorks the truss, let's go over here. I clicked File, and I am going to select Import Step File, and I'm going to double click on the truss. This is the part that we're going to be building. Right here in front of us, Camelot is asking, do you want to detect features? Now, what it's asking to do is to go through your entire structure and find every different kind of tube in it. So a tube, for instance, could be, in this case, we're doing 1.5 by 3, 125 wall, so that's all it's really going to find. But you could have other sizes of tubing in your structure, just different wall thickness, different sizes, and Camelot will go through that, find all of the different sizes, organize them into different jobs so that you could go out to the machine and create it. However, for this application, it is just one size of tube. So let's go ahead and select, yes, I do want you to detect features. And you'll notice Camelot will be popping up a screen here in a minute as it identifies these individual parts. And what it's asking right here is, do you want to make a job for that? We're going to say yes. Now it's going through the individual parts. Now a job is going to be the file that we are going to tell Camelot where to make the cuts. Do we want to put special markings on it, which we are in this project, things like that. So you can see the progress bar down here. Camelot is going through that entire structure. It now wants us to save the job. We're going to save it as floor truss, yes. And there we go. We now have a job created for this part. Let me go ahead and show you some of the things you see on the screen, since this is a tutorial of how to use Camelot. Right here in the central viewport, you have 3 tabs. One is tube view, and what that's going to do is when you come over here to tube parts, if you select the different parts, it is going to allow you to see what those individual parts look like. If we go to part view, you will see the entire structure, in which case you could come along and select a single part here, and it will highlight it over here, so that if you go to tube view, there's that particular part right there. Now the nest view tab isn't showing anything yet because we haven't created a nest. Let's look over here on the left side. You obviously now know what tube parts is doing. We just select on the individual parts. In this particular panel here, we can override by double clicking, for instance, the number of parts that we may want to make. In this case, we're not going to want to make any more than one because we only need 1 truss. Now down here in the layers panel, when Camelot creates structure like what we're seeing in a job, it's going to break things down into layers. Now a layer can contain a number of similar items such as contours, markings, things like that. Well, what we call a cuts layer is typically what you see on the screen in front of you, the ends of a structure or a piece of tube. Now, if these parts had holes in it, they would have been placed on the layer holes by Camelot. Also, if there was markings on it, such as part numbers or a logo that you may have imported to DXF and placed on your part, it will also place markings into a separate layer also. Now, if we come up here to tube nestings, we have not created one of those yet, so therefore it is empty. And down here in the lower left is where we create our operations. So let's go ahead and do that now. To create an operation, come down here to the lower left panel, Operations, and click on the plus sign. And that will bring up our Operations dialog box. We have a PowerMax 85 selected. That's what's on the machine. We set that in the main settings in Camelot. Now, Camelot has gone through and already determined that the metal thickness is 125 wall, so we don't have to do anything there. Now, if we look right here, we have layers. We only have 1 layer, cuts, because that's all Camelot could find. That's all there was in that structure. Right here, we have the contour offset, and we could change the offset. I've shown that in similar videos or earlier videos, such as the card holder video. And essentially, you're going to want to place the kerf half of the distance away from your contour that you want to cut, the kerf being the slot that the torch is cutting through the part. So Camelot is going to look up into its database tables supplied to us by the plasma power unit manufacturer and determine what that kerf is. Now we need to go ahead and select 45 amp shielded because that's what we're dealing with on the machine out there. Now it's going to offset it 17.5 thou. We're going to go ahead and pick outside offset and select OK. Alrighty. So what we're doing now is if we zoom in and we look at the different parts, let's go here. I want to show you. Okay. You could see where we have applied an offset, but we have applied it the wrong direction of the tube. You can see that we've actually offset inboard. Now, I'm going to tell you straight up, this is a recently identified bug. It's a very minor deal. It's not a big deal. However, rest assured, we are in the process of fixing that. So let's go ahead, go back to our operation, left click on it, and edit it. And instead of an outside offset, which is the correct method, we're going to go ahead and select inside to temporarily move it to the other side. Now this bug evidently came about because we are adding structural shapes to Camelot, angle iron channel, and we've had to change the algorithms that are handling the contours, and evidently we made a slight mistake there. I wish we were perfect, but we weren't. Good news is we write the software and we can fix this problem relatively quickly. Let's go ahead and say OK. Alrighty, now if you noticed, we are now correct. If I zoom in right here, you could see where the cut path has now been offset to the outside of the part. We're actually good to go if we wanted just to go out there and cut these, but we don't. We want to go ahead and use another feature in Camelot because, as I said earlier, all of these diagonals may be slightly different from each other. So it would be of great help if we could number these, and a Camelot will allow us to do that. So in order to do that, we're going to go up and we're going to select text contours and we're going to select part numbers. And we're going to come over here, and if you look, it says part underscore, and then it's got the squiggly parentheses and a 0 in the middle. Now what the squigglies are going to do is apply this auto incrementing number. So if we do this to all of our parts, it will auto increment the number 1, 2, 3, 4, 5. Now, this part in front of it, we could put whatever we want on it. You could type in a part number, whatever you want. We're not going to do that because we just want a number that the welders could refer to that number on the drawing and know their place in that part in the right spot. Let's go ahead, and if I zoom in over here, you can actually see what it's going to put out, right? Part number 9, because I haven't updated anything yet. Let's go ahead and increase the size of the scale. I want it a little bit larger, and I also want to move it over about 3 inches because I know that's a safe distance on what we're doing on this part. Now, if I select center Y, let's zoom out here a little bit, it moved it to the other side over there, but it centered it on the part, which may work good. So let's go ahead and update our text. Now we just have our number 9, and we go ahead and apply it. All righty. Give it a second to apply. All right, we did all that. Let's go ahead and close this tool. Now, if we were to go look at the different parts, you see the number right here? 13, 11, 12. So we now can make an operation to put these part numbers on those parts out there. So once again, let's return to operations and click the plus button. But this time, if you notice over here, we have a new layer called part numbers. So we are going to select that layer and we are going to use the marker. Now we could scribe it. If we scribe it, it's a permanent mark in your metal. If we use the marking tool, it could be later removed with acetone or something like that. Notice there's no kerf width settings because we are not cutting a slot. We are basically working right in the middle of the tube, or right in the middle of the contour. Alrighty. So we now have both of our operations. The next thing we're going to want to do is nest everything. Before I do that though, I'm going to go over here to File, and I'm going to select Save Active View As. And I already saved the first one as floor truss, right? I'm going to go ahead and save this one as a different number. And the reason I'm going to do that is I learned the hard way using another software that I used for over 2 decades, and it crashed so many times that it got me in the habit of saving often. So that's what I did. If you notice, the file name changed up here, and the reason I did it was if I make some kind of irreversible mistake, I could simply go back and open up that file and continue on where I was. Camelot has undo and redo features, but only up until the time when you accept what you're doing or you save your work. And just like all CAD programs, that's the end of your undo train right there. All right, so let's go ahead and create our nest view. Before we go in nest, let me show you something else down here in the operations panel. We created the layer cuts first, remember? And then we created the part numbers to place on the tubes. Well, when Camelot orders all this, it may come along and cut off both sides of the tube, then try to mark. Well, it can't do that because the tubing is now fallen out of the machine. So what we're going to want to do is reorder the operations over here. So I am going to hold down the left mouse button on layer parts, and I am going to drag it up one, and you can see where now it's a higher layer. So it's going to do this operation first. We are currently working on a very intelligent part ordering scheme to where Camelot is going to come along and auto order everything for you, and then give you a couple of options of how you want it to auto order those contours. So look for that in the near future. Okay, now we're ready to go ahead and nest our tubes. Looking up at the ribbon bar here, you'll see a nestings group. We are going to select nest tubes, and that will bring up our nest tubes panel over here. This is a tutorial video, so I am going to explain a few things. If we want to, from the point on the tube that we tell Camelot to start cutting, not necessarily the end of the tube, because remember, when you take a program out to the machine, you're going to move the cutting torch to where you want that program to start cutting. It's 0 point. What the front spacing means here is, do I want to move that start in a little bit? Maybe say, I don't want to start where I'm telling you I want you to start 5 inches inboard. That's what that does. Mid spacing is the distance between parts. Right now, this is a work in progress because we are creating the full automatic nesting, a very intelligent nesting where Camelot will rotate all the parts, fit them together, trying to minimize the amount of tubing used. That will be fully automatic. Look for that in the near future. Back spacing is just how much distance you want Camelot to leave at a minimum between the last cut and the chuck that's actually rotating the parts. Now, right here, this is an important number. It's basically the length of your raw tubes that you may have bought from the supplier. Now, the length of tubing that we've got for this job is 24 inches or 24 feet, 288 inches. The maximum cutting capacity travel of the machine with the square stabilizer in it is 21 feet 9 inches. It's not a problem for our job. However, you'll see what's getting ready to happen here in a minute. So what I could do on this part right here is lie to Camelot and tell it that I don't have 288 inches. I have, let's bring our calculator over here. All right, 21 times 12 plus 9. We have 261 inches. So I could lie and tell Camelot that, which I think I will do. Let's see. Normally, most people are purchasing 20-foot lengths of tubing, which gives us, plenty of travel, plenty of room. But in this particular case, they ordered 24 inches. Okay, now if we look over here, this is where we can select a part here. It'll highlight it up there, and we could select the desired number that we want to cut. Now, the guys out there have already gone ahead and cut all of the straight lengths to length at a saw because, let's face it, that's the best way to do it. We could have done it in Camelot, but it would have just, been more work for no real reason. So what we're going to want to do is take these parts and set the desired number to 0. Also, these straight parts, these right here, 1, 2, 3, those parts, we're also going to want to set them to 0. And if you notice, they're 14.6 inches over here. They're really 14.625, but Camelot is rounding that up. I'm going to change that to where it actually puts out the real thousandths number. Let's say we don't want to cut 10 of those, we only cut 0. So we're going to go ahead and change this to 0, 0, 0, and one more 0. Okay, now Camelot, when we go to nest, it's only going to process the ones that have a desired number next to it. Over here, I can override this desired number by selecting this and then basically coming over here and telling it what is the number I want to override by. And it will take this entire listing here and multiply it by whatever number we put there. So if you wanted 10 trusses, you could override desired number, put 10, and there's your go. There, you're going to end up with 10 trusses. Over here on the left, we have tube nestings, and this is where if you hit the plus button, I can enter an existing piece of tube out there. So let's just say I have a piece of tube out there that's 122 inches long. I can go ahead and enter that. Now look what Camelot did. When I go to nest view, instead of being empty, it is now showing us that 122-inch length of tube because it has one to work with. However, we're going to go ahead and remove all nestings because I do not have a 122-inch piece of tube. I made it up. Okay, at this point in time, let's go ahead and hit nest tubes. And just as fast as you could blink your eye, it did it. And what it figured out is right here, we're going to need 236, what is that, 0.54 inches. You can actually, it'll show it to you right there. That's how much tubing we're going to cut for the very first file that we load onto the machine. Now the second one is much, much shorter. We're only going to need 103.5 inches of tubing. All right, now, if you come in, if you zoom in, you can see what I'm talking about on the smart nesting. If we could have flipped this part 180, we could have slid it towards this part, saved ourselves maybe, I don't know, half inch, an inch of tubing. That is currently what we're working on when I mentioned the smart nesting. Now all we have to do is run the post processor, and it's doing its thing, and it is now creating G-code that we're going to be able to put onto a USB, take out to the machine, and cut these parts out. It's going to be creating 2 files. So there's our G-code right there. Now, if I go over here to net 2, you see the code right here listed? It's G-code for nest 2. If I go here, G-code for nest 1, it's different G-code. So we have 2 separate files that we are going to take out to the machine. However, before we go out there, let's verify that Camelot has indeed generated code that's going to work for our application. So we're going to go to Animate, which is now active because I did run the post processor. And if you look right here, we're at the very beginning of the program, and you can see it is going to draw that number 24 first. Now, if we go over here, we can manually drag this thing along and see where it's going to go. It's going to cut the end, then that one, then the marking. And as you can see, it is going in the correct direction. Let's zoom out a little bit. It's going to happen a little fast. It occurs to me that maybe we should put ourselves a speedometer over here, or some kind of throttle, how fast this thing goes through it. But if you look at it, it is going in the correct direction. It should be fine. Let's go ahead and stop that right there. We're going to go back to the job. Now what we want to do is we've already created the code. We verified it that it's correct. Let's go ahead and save the G code. It's going to come up and ask, what do you want to save it? So I'm going to save it as floor truss. We'll say OK. And now it wants to know where would you like to place it. So let's go to my Nextcloud code. Alrighty, customer files, Devon, and we're going to put it right there. Open containing folder, sure. So right here is the 2 programs, basically this program right here. Let me see, where did I go? Okay, it is those 2 programs. Now, all I have to do is pull my drawing up that we showed earlier and mark which tubes are what on that drawing. Remember, I have a drawing right here. Camelot does not currently have the ability to create its own drawings. That is something we plan on probably working on next year. However, I can take this drawing, print it out, go back into Camelot, go back to the part view here, select, for instance, if you look at the drawing, we know that we have one side that has 4 elements. This side has 4 elements, but this one only has 3, and this one has 5. So we know how to orientate this thing as far as our drawing goes. Let's see here. Let's get back to it. So all I need to do is select one of the items, and we'll select it on the 5 side. And let's go see what item that is. All right, that is number 17, right? So I am going to pull up this drawing, and I am going to make this here 17. And then we're just going to march down the line. That one is 16, 15. So let me go ahead, go off camera for a minute. I will do that, and then I'll show you the finished result. What I did off camera was I printed out the drawing that I had made up earlier of the truss, and then I identified, I went into part view, I clicked on this part. Notice it's truss 24. If I go to the next one, it moved up to 23. This is going to be 22, 21 right on up. And if you get up here, we're going to see that it's number 9, and then it's going to be 10, 11. So I took those numbers and I wrote them onto the drawing to identify which of these angled segments are going to be identified by the number written on them. So that's all I did just now. It's very, very easy to do. I was just informed that they need this part pronto quick, so we are not going to do the next feature that I was going to show you, which is basically called wiring. And what it is, if you want to see it, I did it in project 1 under the card holder. Essentially, we would pick this part right here, and then using the wire marker functions in Camelot, we could draw this where these tubes here match to this one. We could draw it on it. However, we don't really need to do that because we do have this drawing that the welders are able to work off of and create this. So at this point, we are literally just going to go ahead and take our 2 NGC files, our numerical code, and head on out to the machine and cut it. That's it for the segment on using Camelot for this. I really want to thank you for watching. If you've got any requests or anything, please don't hesitate to email support or sales. Send them pictures if you want, and I'd be glad to help you out, possibly make a video showing the world what you're trying to do. Anyway, thank you very much for watching again. Hope you have a great day and look for the next projects. Bye.